if each of the following graphs is the graph of a polynomial, then identify which one corresponds to the linear polynomial and which one corresponds to the quadratic polynomial. So we have given with 3 graphs. This is our first one. We call this one as a parabola. This is a straight line, and here we have a curve which touching 3 points on the x-axis. So in a graph touches 2 points on the x-axis, then it is a quadratic function, or it's a quadratic polynomial. We call him by a pet name parabola. So this is a quadratic polynomial. Here, this is a straight line which touches the x-axis exactly once, and it is a graph of a linear polynomial. So this one is a linear polynomial. It's touching more than 2 times, so it's not a quadratic polynomial. So it's neither linear nor quadratic. Next one, find the zeros of the quadratic polynomial x square plus 7x plus 12 and verify the relation between the zeros and its coefficient. So here we have a polynomial, the quadratic polynomial x square plus 7x plus 12. So we need to verify the relation. First of all, find the zeros of this quadratic polynomial, and we need to find the relationship between the zeros and the coefficient of this polynomial. Coefficient means the coefficient of x square, coefficient of x, and the constant term. So first let me factorize x square plus 7x plus 12. X square plus 7x plus 12 can be written as 7x can be splitted into 4x plus 3x. Now you can see that here we have an x common, here we have 3 common. So from here I am taking x outside. So x multiplied with x plus 4. Here I am taking 3 outside. So here also there is an x plus 4. Now in this part we have x plus 4 common. So I can write it as x plus 4 multiplied with x plus 3. Now we have factorized the f of x square plus 7x plus 12 into x plus 4 into x plus 3. So to find the zeros of the polynomial, we need to equate this to 0. So x square plus 4 into x plus 3, that is equal to 0, which implies x is equal to negative 4, which if to product of two real numbers is equal to 0, that implies either first one is equal to 0 or second one is equal to 0. So x plus 4 equal to 0 or x plus 3 is equal to 0. Here then we have x is equal to negative 4 or x is equal to negative 3. So we have two values for the quadratic polynomial x square. The zeros of the quadratic polynomial, they are x raised to minus 4 and x raised to minus 3. Now let me consider the values of x, that means the zeros as alpha and beta. So I am picking my alpha as negative 4 and beta as negative 3. Now alpha plus beta is equal to negative 4 plus negative 3, which is equal to negative 7. Similarly, I am finding multiplying the terms, I mean the roots, I am multiplying alpha dot beta. So alpha beta is equal to negative 4 multiplied with negative 3, which is equal to positive 12. Okay. Now this was our polynomial f of x. F of x is equal to x square plus 7x plus 12. Now you can see that if we add the roots, we have alpha and beta are the roots of this f of x. When we add, we have the answer as negative 7. You can see the coefficient of x, that is positive 7. You can also see that product of the roots alpha beta, that was equal to 12. In fact, our constant term in our f of x, that was also equal to 12. So the coefficient of x square is equal to 1, coefficient of x equal to 7, and constant term which is equal to 12. Now I can say that the coefficient of this one, that is sum of the roots, that is equal to negative coefficient of x divided by coefficient of x square. So alpha plus beta, that is equal to negative coefficient of x divided by coefficient of x square. So negative 7 divided by 1, which is equal to negative 7. Now the constant term, that means the product of the roots alpha beta is equal to coefficient of the alpha beta is equal to constant term divided by coefficient of x square. Constant term divided by coefficient of x square. So we have our constant term as 12 divided by 1, which is equal to 12. Next one, find a quadratic polynomial each with the given numbers as the sum and the product of its zeros respectively. Okay, so they are asked to find a quadratic polynomial. We know that the sum of the roots, that will be the coefficient of x, and the product of the roots, that will be the constant term. So any quadratic polynomial can be written as the form f of x, that is equal to k is a constant real number other than 0. So k multiplied with x square minus sum of the zeros multiplied with x plus product of zeros. Any quadratic equation can be represented in this form. So we have the sum of the roots, that is 1 by 4, and product of root, that is negative 1. So we can replace sum of the zeros with 1 upon 4 and product of the zeros with negative 1. So we have f of x is equal to k multiplied with x square minus 1 by 4x minus 1, which is equal to, so this is our first polynomial, I mean the polynomial, the quadratic polynomial f of x is equal to k into x square minus 1 by 4x minus 1. Next one, we have the sum as root 2 and the product is 1 upon 3. So, as usual, we can write that as in the form k multiplied with x square minus sum of the roots multiplied with x plus product of the two. So, that is equal to x square k into x square minus root 2 x plus 1 by 3. On simplification, we have k by 3 into 3x square minus 3 root 2 x plus 1. So, this is our next quadratic polynomial with roots with sum of the roots as root 2 and product of the root as 1 upon 3. Okay, next one, sum of the root is equal to 0 and the product of the root, that is equal to root 5. So, we can write that as the form k into x square minus the coefficient of x, that will be equal to 0 and the product alpha dot beta, that will be equal to root 5. So, we have k multiplied with x square plus root 5. So, next polynomial, that will be of the form q of x is equal to k into x square plus root 5.